When you hear the Big Bang, your brain probably cues up exactly this: a massive, fiery explosion blasting matter into an empty, pitch-black void. But that mental image is entirely wrong. There was no explosion, there is no center of the universe, and matter didn't suddenly rush out to fill up a vast, pre-existing empty space. Instead, what actually happened was an expansion of space itself. The expansion didn't happen at one specific point. It happened everywhere, all at exactly the same time. Holding on to the explosion myth keeps us stuck in a standard, everyday sense of physics. Letting it go is the only way to actually understand the bizarre mechanics of how our reality operates. Which brings up an obvious problem. This happened 13.8 billion years ago. Since no one was around to witness the universe's first seconds, how can scientists possibly know any of this is true? Cosmologists work like forensic detectives. They measure the exact state of the universe right now, map out how things are moving, and then simply run the physical timeline in reverse. This timeline is reconstructed from the hard physical evidence we can point telescopes at today. In the 1920s, astronomer Edwin Hubble made a foundational observation. By analyzing the light from distant galaxies, a phenomenon known as redshift, he realized those galaxies are actively moving away from us and from each other. Imagine a balloon covered in tiny dots. As it inflates, the distance between every single dot increases simultaneously. Notice no dot is the center of the surface. From any dot's perspective, all others move away. This is exactly how space expands, uniformly, everywhere at once. If space is stretching out right now, basic logic dictates that yesterday it was smaller. And if we rewind the clock all the way back, every piece of matter in the universe must have once been infinitely close together. Reversing the timeline 13.8 billion years, we watch the cosmos contract. All matter and energy crashes inward, crushing into a single, intensely glowing microscopic point. Physicists call this initial state the singularity. It is a moment of infinite density and heat, where the current laws of physics entirely break down. Now we hit play. We move through the mysterious first fraction of a second, known as the Planck era, straight into a phase called inflation. Here, the universe expanded exponentially, growing much faster than the speed of light in mere fractions of a second. As the cosmic expansion continued, the extreme heat allowed the very first fundamental particles to form, quarks and electrons. Within minutes, these particles began binding together in a process called nucleosynthesis, forging the first simple atomic nuclei of hydrogen and helium. In just a few minutes, the universe manufactured the raw building blocks for every star, planet, and person that will ever exist. We jump forward 380,000 years to a milestone known as recombination. The universe finally cooled down enough for those wandering electrons to lock onto the nuclei and form stable atoms. Before this moment, the universe was a superheated plasma that trapped light, making the cosmos opaque. But once stable atoms formed, the fog lifted, allowing the very first light to travel freely across the universe. This map shows the exact pattern of that ancient light, which is still visible to us today as the cosmic microwave background, or CMB. It reveals a uniform distribution of residual radiation stretching across the entire sky. The CMB is a baby picture of the cosmos. Its existence provides physical, measurable proof of the hot, dense initial state predicted by current physics. From there, gravity took over. Over billions of years, it pulled drifting clouds of gas together to ignite the first stars, slowly assembling the massive galaxies and clusters we observe today. But the timeline doesn't stop here. When astronomers look at the modern universe, they see that it is still expanding. And driven by an invisible force we call dark energy, that expansion is actively accelerating. This leaves physicists grappling with massive unsolved mysteries. We still don't know what actually caused the expansion to begin, or what exactly dark energy and its counterpart, dark matter, really are. Dropping the outdated image of an explosion reveals a clearer picture. The Big Bang exists as a continuous, ongoing process of cosmic expansion. We are actively living inside that expansion right now.